Welcome everyone to this new and very exciting ROS course called A Systematic Approach to Learning Robot Programming with ROS. I'm Juan Rojas and I'm part of Guangdong University of Technology in the Biomedics and Robotics Lab. Well, I told you my name, but in fact my real name is very long. You can call me Dr. Juan Luis Rojas Suarez del Real. For short, call me Dr. Juan. Where am I from? I was originally born in Mexico City in North America. Mexico is a beautiful country with much history, nature, culture, and traditions to share. Here is a brief video. Certainly, you will be learning about ROS in this class, but maybe you'll learn some about me and my background as well. Where did I study? After turning 18, I went to Vanderbilt University in the United States. It's located in Nashville, Tennessee, and it's one of the most beautiful campuses in the United States. Vanderbilt is currently ranked number 15 university in the United States overall, and number 1 for happiest students in the country. It's an incredible place to study. What is my favorite sport? This is an important question for me because I played American football from 7 years old all the way to college. In fact, this was one of the main reasons why I decided to go to the United States to study. This was a big part of my life and defines a big part of my character. And if you want to know my current experience as a robotics professor, I can share with you that so far in my 14 years of research experience, I've been able to publish more than 35 international journals, conferences, and workshops at top level. I've had experience with many robots, including here on the top right, our homemade dual arm pneumatic actuator humanoid robot that I worked in graduate school. During my postdoc years, I had access to HRP robots in AIST, one of Japanese premier research centers. Currently, in my professor experience, I had a chance to cooperate with Hong Kong University when the DARPA Robotics Challenge took place in 2015 and worked long distance with the Atlas robot. And in our lab, we have robots like the UR5, the Kuka Iwa, and also the Baxter humanoid robot. It is this robot which will take the main focus in our course because it has a great simulation environment that is easy to access, and we'll spend most of the time with him, although we will touch other robots as well. What's my research? Most recently, I've been really interested in intelligent robot manipulation and something called robot introspection. Introspection means helping the robot understand what's happening inside of him. We're interested in helping the robot understand what are the actions I'm currently performing, and when unexpected events take place, what do those mean? What do they do? Let me show you a video of some experiments we did recently where a human will be colliding accidentally with the robot while the robot is performing a task. We have an intelligent module here based on hidden Markov models that is trying to model different actions that the robot experiences. And on the right side, we have a graph that controls the behavior of the robot when unexpected events take place. Sorry, let me find my videos. Here we go. So the robot task commences here, and when there's a collision, the system is able to identify it here and issue a recovery behavior for that stage of the robot. In this case, the robot was trying to grasp the block where another collision took place and a new recovery behavior was affected. In this location, once the pick and place has occurred, the robot will return to a safe position before moving forward with the pick and place motion. In this experiment, we are abusing the robot, colliding with him at many locations across the experiment and showing that for each of these situations, the robot returns to a safe position before executing its next motion. As you see me switch between windows, you'll notice that I am moving between the Windows operating system and the Linux operating system. So every time I switch, that's what's actually taking place. Let me introduce some aspects of our course in order to start off with the basics. Let us begin with language. Currently, many aspects of the class are in English, but we are working to facilitate understanding. At the end of this course, we will have a project, and all of these will take place in English with subtitles. Our main book that we will use in our course will also be in English, but the supplemental books can be read in Chinese. I will introduce those later. Homework can be submitted in Chinese, though English is preferred. The same final project can be submitted in Chinese as well, and English again is preferred here. When you take this course, you'll have a great opportunity both to improve your robotic skills, but also your English. So you can think of this as being twice as good for your money. For a class overview, we will start by, after installation, we will start by understanding one of the most basic concepts in ROS, which is the network. So we will study the graph, the nodes of that graph, and different communication schemes like topics, services, and actions. After that, we move on to simulation. Simulation will be a key part of this class and is a key part for industry and research in order to test our robots and our algorithms. We'll be learning a lot about URDF, SDF, and Gazebo first, and later different visualization abilities through RViz. We then dive into vision, looking at camera calibration, visualization of images, color, monocular, stereo, depth images, and further on with point cloud images. We move into our fourth module of manipulation, beginning with low-level control, understanding how manipulation is affected in different ways. Then we study motion planning and end with grasping. All of these things can be brought together under system integration, where we will have an example of mobile manipulation, which will be very interesting and useful in real-life circumstances. For our class, we will have one teacher assistant who is Chinese. He's one of my current students whose name is Chen Xiang. And he will be assisting me both with weekly support through the QQ group with all of you. The main textbook for this class is currently available only in English. It's called A Systematic Approach to Learning Robot Programming with ROS by one of my friends, Wyatt Newman. The reason I chose this book for this course is because I believe this is the best textbook out there to teach ROS. It is very systematic, and it will help you to learn principles as you understand more of robotics. Additionally, the book is not only focused on ROS, but also on robotic concepts. So together, it offers a really powerful textbook. It's a brand new textbook that has just been released this September. So no one else is teaching this course besides Wyatt and myself. We have 2 other books that we will use from time to time in our class. These are the ROS by Example books by Patrick Goebel, which have been very popular around the world. The books also come with great support in terms of code and support groups on the internet. Patrick has done a fantastic job and has been updating his textbooks for the last 5 years. Him and I paired up to translate these books and now are available on all of the main Chinese websites like Taobao, JD, Dangdang, and Amazon, and you can buy them easily there for both of them. The first one is ROS Rumen Shili, and the second one is ROS Jinjie Shili. Please look for them. As part of our MOOC grading system, all homework will consist of green, yellow, and red passes given to each student. I expect to provide weekly homework assignments that may take 2 to 3 hours to do to help you improve your understanding, but also your coding skill and robot execution. Homeworks will often involve both questions that test your understanding of concepts and then practicing programming the things that we visited in class. The final project can be in simulation or a real robot if you have one. It'll be a great time to push yourself forward and implement more challenging behaviors. We will also provide green, yellow, and red cards for the final project. Here is a list of useful websites that I think you'll find appropriate for what you're doing with me here. The first one, of course, is the ROS.org website, the main website for ROS, and you'll find excellent tutorials here on a wide range of issues as well as package descriptions. The second website is ROS Questions and Answers. Anytime you have a question, this is a great place to look to see if the question has been already asked, or if it hasn't, you can ask the question for the first time. Since we're going to be working with Baxter a significant amount, Rethink Robotics, the company that created Baxter, has an SDK website where you can learn a lot about the details of the robot and all the supporting software that they have created for it. In terms of Chinese websites, we have 2 that have been very popular. The first one is xbot.net, but you can also visit the blog. Great ROS support in Chinese with many tutorials and support available for all in China. A second and similar website is rosclub.cn. However, this website seems to focus more on robot navigation, nonetheless useful resource. In terms of class communication, please understand that my Chinese is still currently limited. 我可以说中文，但是不很多。For this concepts so that you can understand. Okay, getting started. There's going to be 4 things we're going to be focusing on today, and part of those you'll need to do as homework for this first week. I will give you step-by-step guidance as much as time allows in this video, but some of this work you will have to do at home. The first step will, of course, be to install Linux. Once we have that, we'll install ROS. And after ROS is installed, we will install the book code that we will be using for the rest of the semester. And then you'll have a time to learn more about Linux, Python, C++, Git, and a host of other issues. Okay, installing Linux. The first thing that you want to pay attention to is that we are installing Linux 14.04.5. Currently, if you visit Linux Ubuntu website, you'll see that we can install up to Linux 17.10, I believe. But it's very important that you keep this version of Linux Ubuntu at 14.04.5. Now, Linux can be installed in 3 different ways, and you'll be able to choose which one favors you the most. I'll be telling you which one I think is the best option when you want to run pure Linux and ROS. The XBot website has some Chinese tutorials to help you with the first 2 ways of installing Linux. Okay, the first way, which might be most simple, is to have a dual operating system installation. Ubuntu has a standard tutorial to do this installing of dual boot systems with Windows. So in this case, Windows will be the main operating system, and Linux will be the secondary operating system. And it's at the beginning of when you start your computer where you get a choice about which one do you wish, which operating system you wish to run. I prefer virtualization as a choice, as a recommended choice for all of you to run. I use this free open source software called VirtualBox. And with virtualization, you have 2 choices. One is running the Windows host with a Linux guest. Now, this is not a great choice once we start using the Gazebo simulator, because in virtualization environments, we have to divide the memory. Some of you may experience a very slow system when we run Gazebo. Additionally, there might be some OpenGL limitations when we run Linux as a guest in the virtual environment. Though this is very easy to run, and it's a possibility. My favorite choice is this one right here, 2B. I prefer running Linux Ubuntu as the main operating system and then running Windows as a guest. This link will provide you with some instructions on how to do this. But just to demonstrate, let me switch over to my Linux environment. So currently, this is my Linux environment. And in a situation where I want to run Windows, I can open my VirtualBox software. In this situation, I can create a new operating system or a host system to run on my Linux host. So here, for example, I could give a name to this guest operating system. I could call it Windows 10 Test. I would say what kind of operating system I'm running and what version. Here, you need to declare how much memory do you wish to allot your system. A good guess might be 50 to 75% of your memory, depending on how you plan to use it. My particular computer has 32 GB of RAM memory, a lot more than most of you. So in my case, I usually use 50% of the memory, 16 GB for Windows and 16 GB for Linux. When it comes to the hard drive, you can choose Create a Virtual Hard Disk Now, where the memory can be selected. And once you do this, you start the system, you will need to provide the installation file for Windows 10 in order for VirtualBox to actually install Windows. I will currently cancel this operation because I have Windows 10 running in my system right here. Once Linux is installed, we will need to start learning how to use Linux. The Linux command shell is different to your normal Windows experience or Mac experience. So I'm now going to introduce to you some of the basic commands for Linux. If you are able to copy this link and click on it, you will open a file that we call the cheat sheet with a summary of commands for the Linux command shell. So I will not go through all of these commands, but I will today point you to some of the most basic commands. Now, the first thing we want to do is open a terminal. We can do that by clicking on the dashboard icon here and typing terminal. This is the common icon for terminal. I have a slightly more advanced software that I'll be using now called Terminator. This is something you're welcome to install a little bit later when you learn how to install software. Once you open your terminal, it'll look something like this. You'll have a longer description here at the prompt. I have changed mine for convenience. So this is called a terminal in Linux, and in this terminal we will be introducing different kinds of commands to interact with our computer. Okay, let's start here with directory operations and learn a little bit more about Linux. PWD stands for Present Working Directory. Once we type it and press enter, it tells us the location where we currently are. And the standard location for a terminal when you open one is the user folder. The user folder follows whatever name you gave to the Linux system. In my case, vmrg user. And this user folder exists under the home folder. If you go back to your dashboard terminal, you can also open something like Windows Explorer. It's called Nautilus. If you click here and then press Control L, you will see that the default location that is called home is also the user folder at home vmrg user here. Okay, let me now jump to this option, ls options. What does ls stand for? It stands for list. How can we know that? There's a special command called man for manual, and by placing the command that we want to learn from after man, we can see a description of the command along with its options. So here we learn about the name. ls means list directory contents. So ls means list. And here we see how this command can be run. First, we can select one or more options that are listed below, and then perhaps a file that we want to examine. Those options are also listed in this cheat sheet, and you can see, for example, that little dash a shows all files, and it does not ignore entries starting with a dot. Now these dot entries in Linux represent hidden files. In Windows they simply don't show up, but in Linux hidden files start with a dot. Now if I want to exit this manual page, you can see that I can press Q to quit. So now I will press Q and I return back to my previous location in the terminal. Now let's use ls for a second. When I press enter, I will see a list of folders and a list of files and folders and my current location. Now notice that there are no hidden files here, and that's correct because we have not used the -A option. So let's try that now. Write ls, add our dash for an option, and then choose the correct option, in this case all. Suddenly I get a very different listing of files and folders compared to before. There's a long list of files like this one, bashrc, that appear as hidden files. I would like to highlight this one in particular because it'll be a key hidden file that we will often go back to set different configurations for our Linux system. If you want to clear the screen, you can press Control L to clear the screen, or you can just press enter a few times to move further down. Let's go back here to directory operations and learn about making a directory. So the command is make directory with the name of the directory following afterwards. So for example, if I want to make a directory called ROS workspace, I can type something like this. And if I want to see if this file was created, I can check with ls. And you'll see here that the folder ROS workspace has been created. The next command is cd. cd stands for change directory. So let's say we want to go inside the ROS workspace. In this case, we would type cd and then the name of the file. Now notice I have not yet finished writing ws. In Linux, the tab button is very useful for autocomplete. If this is the only file with this name, I can press tab and immediately get the full name of that file. So I can say cd ROS workspace and press enter. I can again type pwd to look at the present working directory, or I can look at the top of my terminal right here to tell me the address, my current address. Now notice for this ROS workspace address, we have this sign right here, the tilde. The tilde in Linux represents the user folder. So home vmrg user in my case. If I type pwd, I will automatically see home vmrg user ROS workspace. Now let's look at this tilde sign again and see how it works. If I say change directory to this location and press pwd, you'll see that it has taken me back to the user folder. Let's move into the ROS workspace folder again, and let's create one more folder called source, or src. Now we created it, now we need to move into it like this. Okay, so we once again can move all the way back to the user folder just with the tilde, cd tilde, and we're back to the user folder. If we want to move to the source folder in one line, we can do that easily. Here we just type ROS workspace followed by a / and by source. So you can see that I have moved 2 folders down using the cd command. If we want to go back or up one level, we can use 2 dots to do that. This means go up one directory. So in this case, we would move from source right to ROS workspace, like this. And we can keep calling that command until we have no more places to go. So let's move up one more level, like this. And is it possible to move further up? It is. We can go into the home directory. And the home directory would simply list folders for different users. My computer only has one, so only one user shows up here. Is it possible to go even further up? It is. There is one more level in the Linux system, and it's this one. This one is called root, or the file system. Here you'll see a list of folders that are critical for the correct functioning of Linux. One of the most common ones that we will use in this class is OPT, because this is where ROS will be installed. However, many of other folders are important, like bin. This is where regular commands get saved, as well as user, where local libraries get saved for an individual user. Okay, so let's go back now to our workspace source folder, and we can do that again with one single line. We can say cd home, and I'm pressing tab, vmrg user, ROS workspace, and source. Fantastic. Now, let me also teach you, okay, let's go down and learn a little bit about file operations. So we're going to look on the second page right here on the top left corner. Touch is a very simple system that just lets us to create an empty file. Let's say I just want to create a file called test. So I could just say touch test.txt. Press enter and then check with ls again. I can see that my file is right here. Now this file is completely empty, but I can create it in this way. If I wanted to remove this file, I would use this command called rm for removing. So if I say remove test.txt and press enter, once I call ls, I see that there's no more file here. What happens if I want to remove, say, a directory like this one? Could I use remove? Well, let's try. The first thing I need to do is go up one level so that I can find my source folder. If I try to do remove source, Linux will say, actually, you cannot use the remove command on source because it's a directory. Given that a directory can have many files, remove needs to indicate what exactly should it be removing. If you want to remove everything inside of a directory, you need to give the option R. The R option means recursive, or everything inside of that location. So if I say remove R, source, this time it works. And I can see that I no longer have a directory. But I can just create it again and move inside. Okay. Let's also create our test.txt file one more time. Now, what happens if I want to rename this file? How can I do that? Well, in Linux, we are going to use the command mv. The mv command is to move or to rename a file. Let's say we want to rename test to be test2.txt. So I could write mv with the original file name and then type in the new name. When I do that, I see that my file has been renamed. We can also create a copy of this file by using cp. If we want to copy test2.txt in this location, we can do that and maybe use the name test3.txt. And here we have an exact copy of that file in this location. What happens if we want to copy to a different directory? Let's say one level up. We could then say copy test3.txt, 2 dots to go up one directory, and then the new name. Let's call that 4. So remember, we are here in source, and here we have test2 and test3. If I go up one level and then say, what do I have here? I see that the copied file is located right here. I can also move this file to a different directory. So in this case, I might want to move test4 back to source. So in this case, I would begin typing the folder location. And if this is where I want it to be, I need not to write anymore. Upon doing that, I see that the test4.txt is no longer here, and it should be inside the source folder. There it is. Okay, let me stop here as a basic teaching of Linux terminal. Let us go back to our presentation in Windows. One more thing I would like to teach you with regards to Linux is this program called apt-get. And apt-get also has this cheat sheet. The link is here, but I'm also providing this as a resource or reference file in our class website. Let me navigate over there to the apt-get file. What is apt-get for? Well, apt-get is a command used in Linux to download, to install, download, and update all the software and the computer. The experience of installing and updating software programs in Linux is very different to the experience that we have in Windows. The main reason is that in Linux, we only need one command to update the entire software set for one computer. Actually, that command really takes 2 steps. The first command that we'll see is this one right here called update. Now let me explain a little bit something about update. Because Linux will update many softwares, not just one, Linux needs to have a list of what the latest software is for each of the programs in the computer. This list can be updated when we run this command, apt-get update. Now, apt-get update like this cannot just be run in this way. If you try, you'll get a strange message from Linux saying, I could not open the log file. What this means is that this command right here is an administrative command. You need special privileges to be able to access this command. How do we do that in Linux? Well, we need to use the command sudo or sudo. This command says, I'm going to be a super user and I want you to run a particular command. So if we do sudo apt-get update and press enter, the system will ask for the, after you run this password and press enter, you'll see how this list changes over time. And this is where the system is downloading information for all the different software in your computer. Now, sometimes the system can take a long time or a short time. Let me give you a couple of hints on how you can speed this up. Number 1, let's go back here to dashboard and type software. The first icon that you'll find here on the top left is Software and Updates. If you click here, you'll see that there's a menu right here where you can choose to download the information from the main server, a server for the United States, or other. You can click on Other first, and then click Select Best Server. This will ping all the servers available, including those in China, and through the Great Firewall, and for this reason is slowed down. A VPN can increase the speed of down. Okay, after we do the updates, there's one more command that we need to run, and that is upgrade. Upgrade is where the actual upgrading of the versions takes place. Okay, so anytime you want to upgrade your software, you would run this command. Once you click enter, you'll get some information like this. The following packages will be upgraded, and give you a list. At the end, it'll tell you how much memory you need, and if you want to, where you can find more information. Okay, there is still one more thing about Linux that I want to introduce you to before we continue our installation of other programs. The next thing is Linux editors. Again, unlike be using in ROS. In fact, we're going to use mainly 2 editors, maybe 3. The first one is the most simple of them, at this link or as an attached reference file in our website. A third one is called Vim, but I won't mention it here. Let's return back to our terminal. I will clear this using Control L, and if I want to use gedit, there's 2 ways or more to open this, but one simple way is to type gedit on the terminal. Let me also encourage you to include this editor. So gedit is this simple text editor. Notepad, for example, here you can tell gedit what kind of document you're working with. So for example, if you see different styles would colorize in different ways. If you go with plain text, if you go with plain text, everything will appear the same color. Here you have preferences, the way that it looks, from a classic look to different looks right here. Okay, so this is gedit. Bring it to the side. In fact, let me open my offline version.